this is the output in here, the input in here, that this is, what is it, minus d q sub 1 dt times r sub 1, right? And then this 2. So this is going to be my, what is this? This is L d squared q sub 2 dt squared. Everybody with me? I transform this equation into a little picture, right? Okay. Anybody okay? What I'm going to do from here is, I'm going to change colors here to just emphasize the new steps. In here, I am going to say, okay, how about if I integrate once? What do I get from here? Oh, sorry, I think I need to divide it by that L to be consistent with what we have done in the past. So why don't we just go over here and we say 1 over L, and then of course you have d squared q sub 1 dt squared over here. We integrate once, and what do we have? This one is going to have dq1 dt, right? And then if I integrate another time, 1 over s, I am going to obtain q sub 1, which is now my state variable. And I would love to put this into a scope so I can look at it. But you see what's happening here? Remember my analogy with music? You hear the notes. Here, this is from here. So logic tells you that if you go over here and you multiply it by r sub 1, then this should be completed, right? But you see we have this one here. This guy needs to come from the second equation. So I think we need to do that. We need to now represent the second equation. How am I going to do this? See, the reason I don't get lost in the shuffling here is because I follow a process, and the process is I am following first with the summation points. So let's do that also for the second one. And in here I am going to write it clearly here. The second one is going to have my, so this is this is going to be the L d squared q sub 2 dt squared, like that, this one. And then I need as terms, I need the one that says in here you have this term is this one, right? That has L times d squared q sub 1 dt squared is one of those. Then you have another one that has, in here you have one that says minus 1 over c times q sub 2, right? And then there is another one in here that says minus dq sub 2 dt r sub 2. Remember, this has nothing to do with bone grafts at all. All I'm doing is representing this equation here into this picture. Okay? Everybody okay with me so far? Okay, so let's change the color again so that you'll know what I'm doing. That is a little different, new step in here. I'm just going to multiply by 1 over L over here. And what do I have? I have my d squared q sub 2 dt squared. Go to the 1 over s, and what do I get here? the q sub 2 dt like this, and then I do also one integration more, and I obtain what do I obtain over here? I think right here I obtain my q sub 2, right? See here, this guy needs the derivative here, so it's obvious that this one needs to be multiplied by r sub 2, and then you have just the connection right there. This obviously is a minus sign, plus sign over here. This one comes from q sub 2. So what I would do is, I would do this. Multiply by what I need, in this case 1 over c, and let me see if I can get this right. Okay, but look, I have this one and these are sort of floating in here. This is no problem. You see, how do we complete this one? Once you have it this way, I told you, it's just like music. You hear. See, this guy is calling each other. See, so what do? This thing you just connect it like that. Yeah. And do you see this one over here? That's this one. And so what I would do is, I could go around like that, but maybe it doesn't look as elegant. Well, maybe it is better I do that as opposed to coming it this way. Right? See, from here I need to connect over here. So what do you think from aesthetically? Should I go around like that, or should I cross the lines? It really doesn't matter, but I'm just want a little feedback. Go around? Okay, then we can go around like this, see? There you go. And I have completely finished the block diagram from those second order equations in a very organized way. And this was not a, how can I say, a very simple example either, because it has two second order differential equations, but if you put this into a state space form, you are going to have 4 equations.
That bottom one is a triangle, right?
Which one? This one?
R1? Yeah. All of you. Yeah.
This guy? Oh yeah, this guy. You should have reminded me that in Simulink the symbol here really is like this. We'll do it from now to be consistent from now on. But I think it's important to. So we have the block diagram here completed from the equations of motion. So what I would like to do is save this notes and save this example, because when we continue, what is the next step that I show you on the list over there? Convert it to first order and do the state space form. But I think, everything in small doses. So make sure you understand this, how we generated the block diagrams. Okay, and we'll stop now.